Welcome to today's presentation on multiplexing in data communication and networks. So multiplexing is a fundamental concept in data communication, and here we will need to define multiplexing first. Then we'll move on to explain the different types of multiplexing that we have. So multiplexing is a technique that enables multiple signals to be transmitted simultaneously over a single communication channel. This is achieved by allocating a specific portion of the channel's bandwidth to each signal. So this is a process of combining the data streams and hardware used for multiplexing is known as a multiplexer. So different analog and digital streams of transmission can be simultaneously processed over a shared link. So when multiple senders try to send over a single medium, a device called a multiplexer divides the physical channel and allocates one to each. On the other end of a communication, a demultiplexer then receives the data from a single medium, identifies it, and sends it to different receivers. So we need to I can give an example. We suppose we have three users. We have Alice, Bob, and Fadzai, and these are the three users that we are going to use during this presentation. We have Alice, Bob, and Fadzai who wants to send the data over the same communication channel. So without multiplexing, each user would have to wait for each other to finish transmitting before they could send their data. With multiplexing, each user can transmit their data simultaneously, increasing the overall efficiency of the communications channel. So with the multiplexing, Fadzai, Bob, and Alice can send their data simultaneously, increasing the overall efficiency of the communication channel. Can give a scenario where university campus has multiple departments. We have computer science, we have engineering and mathematics that needs to connect to the internet. Instead of having separate internet connection for each department, the university can use multiplexing to share a single internet connection among all departments effectively, right? So to explain the types of multiplexing that we have, we are going to explain the frequency division multiplexing, the time division multiplexing, and the wavelength division multiplexing. So with the frequency division multiplexing, we are saying that this is a technique where multiple signals are transmitted over a single communication channel by dividing the channel into discrete frequency bands. From the word frequency division multiplex, we are saying that there is a frequency. So we are making use of discrete frequency bands, right? We are dividing the channel into discrete frequency bands. So frequency division multiplexing is an analog technology. So frequency division multiplexing divides the spectrum or carrier bandwidth into logical channels and allocates one user to each channel. Each user can use the channel frequency independently and has exclusive access to it. So all channels are divided in such a way that they do not overlap with each other. Channels are separated by guardbands. A guardband is a frequency that is not used by either channel. So I can give an example. Suppose we have three users that I mentioned, that Alice, Bob, and Fadzai, who wants to send data over a frequency division channel. The channel is divided into three frequency bands: the 100 to 200 megahertz, the 200 to 300 megahertz, and the 300 to 400 megahertz, right? So Alice transmits her data using the 100 to 200 megahertz frequency band. Then Bob transmits his data using the 200 to 300 megahertz frequency band, and Fadzai transmit her data using the 300 to 400 megahertz frequency band, right? This is an example of a frequency division multiplexing, and this is mainly used in radio station. Radio stations use a frequency division multiplexing to multiplex audio streams over a single broadcast channel. So now we're moving to time division multiplexing. And we are saying time division modeling. This is a technique where multiple signals are transmitted over a single communication channel by dividing the channel into discrete time slots, right? So in time division or multiplexing, the shared channel is divided among its users using time slots. You are talking of time on time division, and on frequency you are talking of frequency. So each user can transmit data within the provided time slot only. So digital signals are divided into frames equivalent to time slots. Right, time division multiplexer works in synchronized mode. Both ends, the multiplexer and demultiplexer, are timely synchronized, and both switch to the next channel simultaneously. Can also give an example. We are using Alice, Bob, and Fuzz, right? So we want to send the data over a time division multiplexing channel. The channel is then divided into 3 time slots: 1, 2, and 3. Alice transmits his data during time slot 1. Bob transmits his data during time slot 2. And Fadzai transmits his data during time slot 3. And this one is used in telecommunications company, right, to multiplex phone calls over a single fiber optic cable, right? So we are moving on to wavelength division multiplexing. So wavelength division multiplexing is a technique where multiple signals are transmitted over a single optical fiber by using different wavelength of light, right? So light is different wavelength. These different wavelengths are used to transport different signals. So in fiber optic, multiple optical carrier signals are multiplexed into an optical fiber by using different wavelengths. This is an analog multiplexing technique and is done conceptually in the same manner as frequency division multiplexing, but this one uses light as signals, right? So I can also give an example. We are using Fadzai, Bob, and Alice. So we want to send data over a wavelength division multiplexing. The channel uses 3 different wavelengths. We have 1310 nanometers, 1490 nanometers, and 1550 nanometers. So Alice transmits a data using the first one, the 1310 nanometer wavelength. Bob transmits his data using the 1490 nanometer wavelength, and Fadzai transmits his data using the 1550 nanometer wavelength, right? And this one is used in internet service providers. This one uses a wavelength division multiplex to multiplex multiple data streams over a single fiber optic cable. Now we also need to spread spectrum. Alright, and this one is a technique that spreads a signal across a wide frequency band by using a pseudo-random noise, which is a PN code, right? It uses wireless communication to spread the signal over a wide frequency, making it more resistant to interference and eavesdropping, right? So the features that I have here are wideband signal, and this signal occupies a larger bandwidth than the minimum necessary. So the frequency hopping, the signal rapidly switches frequencies, reducing the chance of interference. We have direct sequence. The original signal is multiplied by a pseudo-random noise, right? The PN that I was talking about, so again, spreading it across the spectrum. So suppose we have a wireless communication system that uses spread spectrum to transmit data. The system uses a pseudo-random, right, noise code to spread the data signal across a wide frequency band, making it more resistant to interference and jamming, right? A scenario is a military communication system uses spread spectrum to transmit sensitive information over a wireless channel, right? This is the application, GPS system, Wi-Fi networks, military communication. Then if you have questions, feel free to ask in the comment section. I'll be able to answer those questions. Thank you for listening to this presentation, and questions are welcome. If you have any questions, just write in the comment section. I will be there to answer you, or else I also make another video explaining what you have missed during this presentation. Thank you.